Hi everyone, in this video I want to talk about something called one-to-one or injective functions. So let's write this down. We're talking about one-to-one functions, and you will also see the synonym for this, same thing, injective functions. All right, so we say a function is one-to-one or injective. So f is one-to-one if and only if each element of the range has only one pre-image. In other words, there's no collisions in the range. And I'll give you a more formal mathematical definition in a minute, but let's get familiar with this concept first. So let's suppose we have our domain and we have our codomain. And let's give ourselves just 2 points in the domain. We'll keep this kind of simple. And we'll give ourselves 3 points over here in the codomain. And suppose our function does this. We take this is not one-to-one. Why? Because there is a collision over here in the codomain. There's an element in our output space, the range. There is an element that has 2 pre-images. So if I were to label these, maybe A and B, and I'll label this point over here, I don't know, star or something. If I look at star, there are 2 elements that map over to it. F of A equals star and F of B equals star. Let's write that down. So F of A equals, that's supposed to be a star, and F of B equals star. And that's a no-no. That means our function is not one-to-one. It's not injective, all right? So let's draw something that is one-to-one, that is injective. So let's draw a new function. So I'll start off here with our domain. I'll put 2 elements over there in the domain. I'll make our codomain here. And I'll put 3 elements over here. I don't really care how many elements there are. And now let's take a look at a function where there's no collisions over in the codomain. So this is an example of a function that is one-to-one. It is injective. You know, it's kind of a silly analogy, but when I think about injections like a vaccine, we've heard a lot about vaccines in the news lately. So here's my picture of a vaccine. That's what I'm really thinking about here, right? There's like the vaccine, it's just poking over to one element. It's injecting into the codomain. It's injecting into the codomain. So that's really what we mean by one-to-one or injective. Let's state this more formally. So here's a more formal definition of injective. So we say F, let's get ourselves a good size marker. F is, and I'm going to abbreviate, one-to-one, if and only if, whenever f of x equals y, and that's something that's happening over in your target space, over in the output space, over in your codomain. So if and only if, whenever f of x equals f of y, then x equals y, right? You are not allowed to do like f of a equals star, f of b equals star. That was our first example, and the a and the b were certainly distinct points. They weren't equal. This is saying if you're going to land on the same point in the codomain, you better have been equal to start with. Okay, so you might be thinking about the sum function up above and whether or not this is one-to-one or not one-to-one. So you want to think about, you know, some of the sets that live in F, and can you think of, let's see, here's a set 7 that maps to the integer 7. Can you think of some other sets that also map to the integer 7? You know, or the 0. Can you come up with some other sets that map over to 0? Are you having collisions over in that codomain of integers?